All right, so in the last lesson, we talked about similar figures and we looked at the properties of similar figures. And today, we're going to use those properties to help us solve for missing side lengths. So if you look at example 1 here, it tells us that given that RSTV is similar, that's what that squiggle line means, to WXYZ, it wants us to find VR. So we are looking for this side length, and we're going to find that by using the property that tells us that corresponding sides have this that are proportional to each other. So the ratio of corresponding sides are proportional. So there's actually 4 sets of corresponding sides in this picture. We can say that VR corresponds to WZ. That's this to this. We can also say that RS corresponds to WX. We can also say that ST corresponds to XY. And lastly, we can say that VT corresponds to ZY. Now notice in all of these that I started with this bigger figure on top and the smaller figure on the bottom. It doesn't matter which one goes on top and which one goes on the bottom as long as you are consistent. Now, based on the property of similar figures, we know that all of these ratios are equal to each other, therefore forming proportions. So we could set all these equal to each other, but we really only need 2 pairs of sides. And so we want to pick the pairs of sides that are going to be most helpful to us or most useful. And in this case, we need to definitely pick this one because that has the side length that we're trying to find. And then we also want to pick this one because that has the other side lengths that give us some information. So we're going to set VR equal to WZ, or corresponds to WZ, and we're going to set that equal to ST over XY. Then we can fill in what we know about this. So VR is X, WZ is 15, ST is 14, XY is 10. And now we have a proportion, and we know how to solve proportions. We've spent a lot of time solving proportions. So in this case, I'm going to use cross products, which tells me that 10 times X is equal to 14 times 15. And then at this point, you're welcome to use your calculator if you would like. So 14 times 15 is 210, and 10 times X is just 10X. We have multiplication, so we undo it with division, and so X equals 21. Now we're not quite done yet because this is a side length, so our final answer is that side length VR, which is what we were trying to find, and make sure you put that side length symbol on top, equals 21 inches. Now, as we talked about in the previous lesson, the shapes are not always facing the same way. They don't always have the same orientation, and so in the last example they were, so we didn't have to rotate or flip either one, but in this one they're not. So we do need to first redraw one of the shapes, and we're going to use this information here, so we know that A corresponds to where L is, so I'm going to keep the ABC and I'm going to redraw this one. So I know A and L have to go in the same spot. I know that B and the letter M have to go in the same spot, and C and the letter N have to go in the same spot. And then I'm also going to fill in what else I know, which is LN is X and MN is 16 inches. And then I'm going to cross this off so I don't get confused. So now my triangles are facing the same way. They have the same orientation, and so it's going to be easier to match up the corresponding sides. So my first pair of corresponding sides that I'm going to use is that AC corresponds to LN. So AC corresponds to LN, and I definitely need to use that pair of sides because LN is what I am trying to find. Now, I'm going to choose another pair of corresponding sides. I have chosen to put this shape on the top of the ratio and this shape on the bottom, and so I need to stay consistent with that in my second ratio. So I'm going to put BC over MN. So now I have a ratio, two pairs of corresponding sides, and again, I know that because these shapes are similar, that their ratios of corresponding sides are equal. And so now I can fill in the numbers for each of these side lengths. So AC is 36, LN is what I don't know, that's X, BC is 24, and MN is 16. Again, I'm going to use cross products to solve this, so I have 24 times X equals 16 times 36. You're welcome to get out your calculators. 16 times 36 is 576, and this is 24x. Again, this is multiplication, so I'm going to undo it with division. And x equals 24. Again, I don't have my final answer yet because you do need to have a unit since there is a unit in the problem. So my final answer is that line segment LN equals 24 inches. All right, why don't you take just a minute and try number 2. All right, so you can see I set up the ratio of corresponding sides. Again, I tried to choose the side lengths that I actually had information about. I chose to put this one on top and this one on bottom. You could have done the opposite. Also, it would have been totally fine if you listed the pair NM and SR first and then LM and QR. That wouldn't make a difference at all. So now I'm ready to plug the numbers in. So LM is 45. QR is 27, NM is 25, and SR is what I don't know. So I have 45x equals 25 times 27. I'm going to use my calculator for that. 25 times 27 is 675, so 45x equals 675. I divide by 45, and x equals 15. So my final answer is that side length RS equals 15 millimeters. Now, one of the ways that this is helpful to us is we can do something called indirect measurement. In other words, we can measure something without actually measuring it, but measuring things around it. And architectures or construction workers would use this to measure things that are inconvenient to measure, like a tall tree or a tall building. And so you'll see this done in this problem. It says at a certain time of day, a person who is 6 feet tall casts a 3-foot shadow. And so they've shown you actually a picture of this. This is the person. And then at the same time, a tree casts an 11-foot shadow. The triangles formed are similar, the triangle that's formed between the height and the shadow. And so it wants you to find the height of the tree. And so again, to measure a tree would be inconvenient, and this is going to give us a pretty good estimate of how tall it would be. So similar to the last one, we're going to set up a proportion. We are going to put the person's height over the tree's height. And then we've got to stay consistent, so the person stays on top. So it's the person's shadow over the tree's shadow. And again, you could have, just like we mentioned in the last one, could have put the tree on the top and the person on the bottom. You could have listed the shadow first and the height second. It would not matter. But now that we have our proportion, we can fill in the information. So the person's height is 6 feet. The tree's height is what we don't know, that's h. The person's shadow is 3, and the tree's shadow is 11. And on this one, we could use cross products, or we could actually see that 3 times 2 is 6, so 11 times 2 means that h is 22. So the tree has a height of 22 feet. Don't forget that label feet, that's important. All right, why don't you take a minute and try this next problem. Again, they've given you a picture to help you out, but you're trying to find the height of the palm tree. All right, so you'll notice in this one I decided to put the tree on the top and the man on the bottom. It doesn't matter, you could have put the man on the top and the tree on the bottom. It would work. There's actually several ways that you could set up this proportion correctly. But once I have it written out, then I can start plugging the numbers in. So the tree's height is what I don't know, that's x. The man's height is 74 inches. The tree's shadow is 80 inches and the man's shadow is 26. You'll notice again, I'm just using this idea of corresponding sides here. So I'm matching up the heights and the shadows and the shadows because they correspond. And now I can use cross products to solve this. So I have 26 times x equals 80 times 74. 80 times 74 is 5,920. Divide each side by 26. And I get that x is 227.69. Again, we always round to the nearest hundredth when necessary. And so my final answer here would be that the palm tree's height is 227.69 inches. And again, it's always smart at the end to go back and look and make sure that your answer makes sense. Obviously, we know we need a number taller than or bigger than 74 because we know that the tree is taller than the man. And so it's good to just look and make sure that your answer looks like it could make sense or is at least reasonable. All right, this one's just a little bit trickier. You can see that we have two triangles. One's actually inside the other one, and so it might be helpful to actually redraw these so that they are separate. So this one would be CED. This is the little triangle inside there, and so this is 30 and this is 16. Now this one also has the point C, but this is CBA. And so this is 24, and CB, which is this side length here, is actually 30 plus X, because it's both of those. Now, I'm going to use the exact same procedure. I'm going to match up corresponding sides. So CE corresponds to CB, and ED corresponds to BA. Again, you'll notice I'm going from the smaller triangle to the bigger one. You could have gone from the bigger to the smaller. I'm going to plug in what I know here. CE is 30. CB is 30 plus X. Make sure you get all of that. ED is 16. BA is 24. Now I'm going to use cross products, and this gets just a little bit tricky, but notice this is 16 times all of that. So 16 times 30 plus X equals 30 times 24. So this should look familiar to you here. This is the distributive property. We are multiplying 16 by both the 30 and the X. So 16 times 30 is 480 plus 16X. Again, that's getting distributed to both of those. And then we have 30 times 24, which is 720. Well, now we have an equation to solve. This is a two-step equation. So I'm going to start by subtracting the 480. Again, my goal is to get X by itself. So over here, I have just the 16X left. On the other side, I have 240 left when I do 720 minus 480. I'm going to divide each side by 16 now. And X equals 15. Now again, we got to look back at our picture, because X was representing EB, or BE, which is what I was trying to find. So side length BE equals 15 inches. But early on in the problem, you might have been a little bit confused, because if you noticed, this BE was not anywhere in our original proportion. And that's okay, because BE was a part of CB, and so it still worked out for us. Let's try one more where we have a triangle inside another triangle. So it wants us to find side length DE, and in this problem we know that triangle ABC corresponds to ADE. So maybe you can see the small triangle inside the bigger triangle. But if that's harder for you to see, it takes just a minute to redraw it, and that could be a very helpful step. So this is ADE, and this is 9, and this is X. And then we have the bigger triangle, which is ABC. This is 10. This side length is 15, because again, we are combining the 9 and the 6 to get that full side length. So now our proportion is that AE corresponds to AC. Again, I've chosen to go from the smaller to the bigger. So then I got to stay consistent. DE corresponds to BC. When I plug in the numbers, I have 9 over 15 equals X over 10. And now I can use cross products to solve. So I have 15 times X equals 9 times 10. So 15X equals 90. And then I divide each side by 15. And X equals 6. So my final answer is that side length DE, which is what I was trying to find, equals 6 feet. And again, you got to make sure you pay attention to what your X is representing. In this case, it was DE.